All right, welcome to The Explainer. Today we're tackling one of the grandest, most ambitious engineering projects ever dreamed up. A literal highway to the heavens, a physical link from a world to the stars.
You've probably heard about the space elevator from science fiction legends like Arthur C. Clarke. He painted this incredible picture of a tower to space, but he also hit the nail on the head when it came to its Achilles heel. It all comes down to one critical, seemingly impossible piece, a cable made of a miracle material that simply didn't exist.
But here's the thing, this wasn't just some sci-fi daydream. For well over a century, some of the world's sharpest scientific minds have been crunching the numbers on this. The idea has been evolving for a long time, from a giant tower inspired by the Eiffel Tower, all the way to the modern concept of a cable unspooled from orbit and held tight by physics. It's a serious engineering problem.
Okay, so if we've been thinking about this for so long, why don't we have one? Let's dig into the fatal flaw, the one thing that keeps the classic Earth-based elevator stuck in the realm of science fiction.
The problem, when you get right down to it, is both simple and, for now, absolute. Earth's immense gravity and the forces from its spin are just too much. The cable would have to support not just the climbers going up and down, but its own unimaginable weight stretching for thousands and thousands of kilometers. We just can't make anything with that kind of strength-to-weight ratio. Not yet. And look, if you need any proof of how hard this is it. Even Google's Moonshot Factory, a place famous for tackling impossible ideas, had to give up. When Google X puts a project into deep freeze, you know the problem isn't just an engineering challenge. It's a roadblock at the fundamental level of material science.
This table really shows you why. That taper ratio is how much thicker the cable has to be at its most stressed point. For steel, the number is, well, it's astronomical. It's a 1 followed by 33 zeros. It's just ridiculously fundamentally impossible. Even with the theoretical promise of carbon nanotubes, we are still waiting on a breakthrough. So an elevator from Earth, right now, it's a non-starter.
But what if we've been trying to build it in the wrong place? This is where the whole story takes a fascinating twist, and we look at an alternative that's actually feasible.
The difference here is just night and day. The moon's gravity is only 1/6 as strong as Earth's, and that one single fact changes everything. The stress on the tether drops so dramatically that the whole project flips from being a science fiction dream to a near-term engineering reality.
So what does that mean? It means we don't need a miracle material for a lunar elevator. That whole bottleneck just vanishes. High-strength stuff we already manufacture today, materials like Kevlar, Xylon, things you'd find in body armor or high-performance sails, they're strong enough to do the job. And to really drive this home, get this. Studies show that a simple ribbon of a material called M5 fiber, about an inch wide and this thick, literally thinner than a single human hair, could support a 2-ton payload on the moon's surface. Think about that. That's a material science feat we can pull off right now.
Okay, so it's possible on the moon. A cool engineering project, right? But it's so much more than that. This isn't just about building something amazing. It's about what it unlocks. This is the real payoff.
The number one advantage is just a mind-blowing drop in cost. You know, we went from the space shuttle's astronomical price tag per kilogram to what SpaceX can do with the Falcon Heavy, which is incredible. But the space elevator, it's not another step, it's a completely different category. It makes getting stuff into space routine and affordable.
So why does that cost matter so much? Because it makes this possible. In Situ Resource Utilization, or ISRU. It's a fancy name for a really simple, powerful concept, living off the land. An elevator makes it cheap enough to actually mine, process, and use the resources that are already on the moon, like water ice and minerals in the lunar soil.
And this right here, this is the killer app. You mine the water ice that we know is at the moon's poles. You use solar power to split it into liquid oxygen and hydrogen, and boom, you have created the most powerful chemical rocket propellant right there in space. It's about 40 times more efficient than launching that same fuel out of Earth's deep gravity well. The moon becomes the gas station for the solar system.
So you can see where this is going. This stops being just about science and exploration. Suddenly, you have a logistics network. The company or the country that builds and controls this highway to the moon wields an incredible amount of power. They become, for all intents and purposes, the Amazon or the FedEx of the cislunar economy. But, okay, let's pump the brakes a little. Just because it's feasible with today's materials doesn't mean it's easy. Building this highway comes with its own set of absolutely massive, mind-bending challenges. So where do you anchor the top of this thing? It can't just hang there. It would be anchored at what's called a Lagrange point.
Basically, a gravitational sweet spot in space where the pull from the Earth and the Moon kind of cancel each other out, letting you park an object there. But here's the catch. That stable point isn't perfectly stable. Because the Moon's orbit isn't a perfect circle, the anchor point for the elevator actually oscillates. It wobbles back and forth relative to the Moon's surface. And not by a little, by over 36,000 kilometers. That is a huge swing.
So this thing can't be a passive static cable. It has to be an active, dynamic megastructure. You have to imagine a colossal winch in space, constantly reeling tens of thousands of kilometers of cable in and out just to manage that wobble and stay stable. And all of this while it's getting peppered by micrometeoroids and needs advanced robots for construction, maintenance, and power delivery. The engineering is immense.
So here's the bottom line. The classic sci-fi dream of an elevator rising from the Earth's surface, that's still on ice. But a highway to the Moon? That is officially on the drawing board. The problem has shifted from a search for a miracle material to a monumental but solvable engineering challenge. And that leaves us with the really profound question for our time. The question is no longer if we can build this road to the cosmos, but who will control it.